Hi everyone, welcome back to my channel. Today we are going to learn about faithfulness versus correctness. These are the two metrics that are used to evaluate the generation aspect of the RAG systems. We are going to see how the generation was correct or not. We validate if our RAG was lying or just wrong. So talking about faithfulness, it's going to give us a measure or validation that the claims that are made by the LLMs are actually supported by the context or not. In simple words, it's just going to check whether the information that the LLM model is providing to the user was actually from the context that was retrieved or not. It certainly does not say whether the answer is correct or not. It just says the answer was present in the context. The formula here would be number of supported claims by the context by total number of claims. The range would be from 0 to 1. Higher the faithfulness, better for the system. So we are going to target something about 0.8, that's 80% faithfulness. What it ignores is whether the answer is actually correct or not. It only tracks the adherence to the context. Let's look at an example and see how it works. Say the user has a query, where and when Einstein was born. From the retrieval, we have a context that says Albert Einstein was born on 14th of March 1879 in Germany. So the answer that the model actually gave is Einstein was born in Germany on 28th March 1879. So here there are two claims. One is the place of birth, Germany, that is correct. That's supported by the context. And then 20th March 1879, that's a wrong claim because the answer was supposed to be 14th of March. So here we only have one claim that is supported out of the two claims that were made. So the faithfulness is 0.5. So it only talks about the generation. What if the context that was provided itself is wrong? We won't be able to verify that with just the faithfulness aspect of things, for which we are going to calculate the correctness. So we are going to check if our RAG system is actually getting the answers right or wrong. So it is going to measure the generated answer, how close it is to the ground truth. That is the right answer. So the formula would be the judge score by max score. We're going to check that. So this we need a ground truth data set. That is, we should be having a golden data set per se. When we're talking about track systems, a sample document where you would validate or you would have perfect questions and answers that you would prepare. And this would be a validation thing that you would compare from the data set to check. Correctness checks against the reality. Faithfulness checks against the context. You need both of them to be high. So if one is greater, the other one is lesser, then there's a problem. To check the factual correctness, we are going to use true positive, false positive, and false negative, for which we will be calculating the F1 score. That is a metric that is used to evaluate the systems, classification systems. So we also check the semantic similarity, measures how close the meaning is, even if the exact words differ. Okay, let's look at an example. So the ground truth here in the previous example was Einstein was born in 1879 in Germany. That's correct. So low correctness answer would be Einstein was born in Spain in 1879. So Spain is incorrect here. So the F1 score drops. That would in turn lead to decrease in the correctness value. So the score tells the retrieved chunk was incorrect, that the retrieval has an issue. Generation problem, the context was retrieved but misread by the LLM. That can also happen. LLM may not understand the intent. The dataset problem, the ground truth itself is wrong. We have to go back and check the dataset. If we compare both faithfulness and correctness, high correctness and high faithfulness is the best for the system. High correctness and low faithfulness, that means the LLM is just answering from its own knowledge. It's not really using the context to answer, it just got it right by fluke or it's a guess. So it's a hallucinated answer. We don't want that. What if it works for one query and it breaks another? It's always dangerous and harmful in production systems. Low correctness and high faithfulness. That means the generation is occurred, the whatever answer the model is giving is present in the context, but the retrieval itself was wrong. It did not get the right context, so or it was incomplete. That can also happen in few cases. So correctness can be low in that case. If faithfulness and correctness both are low, that means the system is not great. It's broke. So it's our responsibility to validate both the measures and see what answers the LLM is generating is adhering to the context or not. So we have to use both of them together to diagnose our LLM. So that's about it for today's video. If you like this video, please subscribe to my channel. Thank you so much for watching. I'll meet you in the next one.